Okay, this is chapter 12, lesson 2. Today we're talking about vectors in 3D, we're talking about notation, we're talking about unit vectors as well, and unit vectors are really important and very useful. So let's get cracking. So we've got the points A and B. Now points A and B are made up of coordinates, which you could think of as being x, y and z. Coordinates have x, y and z axes, x, y and z. Okay? Now, they are coordinates, they are not vectors, they are singular points, they are not vectors. Give A and B an I, J, K notation. Now, I, J and K are all vectors. I is a vector with a magnitude of 1. J is a vector with a magnitude of 1. And K is a vector with a magnitude of 1. If you can't write them bold, just underline them. Now they all have magnitude of 1. I, you could often think of as being the one that heads along the x-axis. It tends to be that way that people think about it, but we've got I, we've got J and we've got K. Now I, any chunk of I, any amount of them would head along this axis here, but just one I would head just there, which would be 1 unit away from the origin. Similarly with J and similarly with K. And what you can imagine is that you've got a sphere all the way around here, and vectors just made up of i's. So if you had if you had just I or negative I, then they would land on this axis and also touch that sphere with a radius of 1. The same goes for J and negative J, and the same goes for K and negative K. They would land on the axis and they would touch the sphere. Okay, they all have a unit. They are all unit vectors, which means they've got a magnitude, a length of 1. Okay, now getting A in IJK notation basically means where is this in relation to the origin? Well, it's really easy to do that. A will equal 2I plus 3J plus 4K. So it'll be 2 chunks along this axis, 3 chunks along that this vertical axis, and 4 chunks along that kind of one that goes through there. Okay. Now this doesn't have a length of 1, this is not a unit vector, but it's made up of individual unit vectors. I, J and K are in the right order. Alright, B, very similar. You've got negative 2I, don't worry if it's negative, plus 3J, and then you've got 0K, you don't need to write it. Okay, you don't have to write it, you can do if you want to, you can put 0K, but really you won't need to. Give the vector AB as a column vector. Now the vector AB as a column vector means that you're heading from A to B, and a good way to do that is to give x2 minus x1, y2 minus y1 and z2 minus z1. Essentially doing this coordinate, take away this coordinate. Okay, so I'm going to do negative 2 take away 2, which is going to be negative 4. I'm going to do 3 take away 3, which is 0, and I'm going to do 0 take away 4, which is negative 4. And take a good look at it. Is it right that if you're going from 2 to negative 2, you would take off 4? Yes. If I was going from 3 to 3, would I take off 0? Yes. If I was going from 4 to 0, would I take off 4? Yes. Okay, that is the vector from A to B. Interestingly, B to A would be the same, but just opposite signs. Okay? Given the magnitude of the vector AB, the magnitude of AB, the notation looks like that. The magnitude is these two lines of the vector travelling from A to B. Well, in this case, that's going to be the square root of negative 4 squared plus 0 squared plus negative 4 squared, which is going to come out as root 32, which will be 4 root 2. Okay? Is AB a unit vector? No, it's not. AB is not a unit vector. Of course it's not. It's not got a length of 1. Next, we've got the vectors A and B are these column vectors. These are called column vectors when you write them vertically like that. Don't put any fraction lines in them, not fractions. 2A plus B would be 2 lots of the vector 2, 3, 4 plus 5, 0, negative 2. Okay, 2 times 2 is 4, add on 5, that's 9. Quick maths. 2 3s are 6. 2 4s are 8, take away 2 makes 6. Okay, that is 2A plus B. Next, that is equal to 2A plus B. that vector there. Okay. Next we've got a minus b, and the vector from a minus b would be 2, 3, 4. The vector 2, 3, 4 subtract 5, 0, negative 2, which is going to be negative 3, 3, and 6. Okay, and that'd be a subtract b, the vector from a, the vector a subtract b. Now those are easy, really, really simple. Those are actually on Foundation GCSE, those styles of questions. But this is more interesting. It says, which of these two is parallel to 6, negative 6, negative 12? Well, you can see from the signs that you've got to have these two signs matching and this one being different. These two signs match this one being different. You know that it's going to be that one. But you do need to be able to actually prove that. And one good way of doing it is you can try to factorize every bracket, every vector into just having a scalar. So you can go with 3 lots of 3, 2, 2. Okay, you can go with 3 lots of negative 1, 1, and 2. Is that one? And then you can go with 3 lots of 2, negative. Oh, sorry. You can go with 6. Pardon me. Lots of 1, negative 1, negative 2. Okay, which is equal to negative 6 lots of negative 1, 1, 2. And so you can see that because of these, the bracket, the coordinate, the column vectors matching, it means that those two are parallel. So therefore this one and the original one up there, they're parallel to each other. It's a nice way of showing it. It's not the only way you can do it. You can do it by multiplying this by negative 1/2. Probably would get you the exact same result. It's up to you how you go about that, but that's just one way to do it. All right, moving on. Find the magnitude of the vector A, which is written in IJK form. Now IJK form in this case is 3i plus 2j minus 5k. All right, fair enough. So we've got find a unit vector in the same direction as A. Now a unit vector has a magnitude equal to 1. Okay, the magnitude of this vector has got to equal to 1. So the first thing is that we're going to find out the magnitude of A and see if that is 1. Well, we know it's not going to because the question is pretty obviously the case that it's not. Take the individual parts of the vector and apply Pythagoras to them. Be careful with this negative 5 when you square it. Obviously you know you're going to get 25, but you know that you need to be adding these things on, so just be a little bit cautious with that, just in case you accidentally put plus minus and square the 5 and then the positive negative thing makes a minus. Okay, you don't want to end up with a negative out of this thing. So we've got 9 plus 4 plus 25. 9 plus 4 is 13 plus 25 is going to be 38. Okay, let me just double check that. Yeah, I'm happy with that. Okay, so that is the length of the vector A. Now, root 38 is around 6-ish. So imagine we had vector A went along like this. Okay, and we've got that whole length there is root 38, that entire thing. Now, if I divided that by root 38, I'd find out just chunks of 1. Okay, root 38 divided by root 38 is 1. So what I can do is I can take the vector A and I can divide it by root 38. Okay, a unit vector in the same direction as A has a really nice easy formula to remember with it. But what we can do is we can say, well, I've got 1 over root 38 lots of 3, 2 and negative 5. You can write it as column vectors, you can write it as IJK vectors if you want to, and so we could write it as 3 over root 38, 2 over root 38 and negative 5 over root 38. I want 1/38 of this thing. If imagine we had a line that had a magnitude of 4 and I wanted a bunch of 1s, well, I'd divide it by 4. If I had a line that had a length of 5 and I wanted a bunch of 1s, I would divide it into 5 chunks. Okay, if I've got a length of root 38, I need to divide everything by root 38. Okay, now a unit vector in the same direction as vector A is equal to A over the magnitude of A. Okay, seems fine. Take your vector and divide it by whatever its length is, and then you'll get just length of 1. And imagine that sphere again. Remember I was talking about the sphere at the start of this lesson. You've got the sphere that's kind of going around like that sort of thing. If I could draw a sphere, that'd be great. but this will be a vector that will touch that sphere. Okay, this one here that I produced will have a length of 1, and you can use Pythagoras on it if you want to. You can have a little mess around with it. Okay, you'd get 3 squared is 9 plus 4 squared plus 25. Okay, they'd all be over root 38, and you could just mess around with that if you wanted to. But that will have a length of 1. Now, your tasks are on page 339, exercise 12a. They are I think actually it's exercise 12b. Yeah, I think it is. It should be 12b, pardon me. 1, 3, 6, 8 and 10 with questions 11 and 12 as extras. Okay, that should say 12b. Okay? Good luck.